Hi everyone, I am Suchithra, working as an assistant professor in the Department of Artificial Intelligence and Data Science in SNS College of Engineering. Today we are going to see about the topic OpenGL Basic Primitives. First we want to know what is OpenGL. OpenGL is a low-level graphics library specification. It stands for Open Graphics Library. It is widely used graphics application programming interfaces that is allow the developers to create 2D, 3D graphics in various applications such as video games, simulation, and graphic user interfaces. Let's see what are the geometric primitives and the image primitives. Here points, lines, polygons comes under the geometric primitives and image bitmaps comes under image primitives. Next we see what are the abstractions. Here the abstractions are GLUT. It's nothing but Open Graphics Utility Toolkit. GLU. It's an Open Graphics Utility Library. Then GL. GL is nothing but Graphics Library. Then we see what are the functions of that. GL2 functions are Windowing Toolkit, that is key, mouse, handler, window events. GLU functions are Viewing, Perspective or Orthographics, Image Scaling, Polygon, Tessellation, Sphere, Cylinders, Quadratic Surfaces. Then we will see the what are the functions of GL. That is the primitives, like we already said, points, lines, polygons. Then shading and colors also the functions of GL. That's graphic. Next, translation, rotation, scaling, viewing, clipping, texture, hidden surface remove. This all comes under the graphics library. Then we go for see the OpenGL architecture. Here we can see the architecture. Here the commands make either accumulated in display list. Here display list, it will accumulate the commands or process immediately through the pipeline. Display list allow for greater optimization and command reuse, but not all commands can be put in display list. Next, we will see the first stage in the pipeline is an evaluator. Evaluator. The stage effectively takes any polygon evaluator commands and evaluate them into their corresponding vertices and attributes commands. Then the next stages pre-vertex operation and primitive assembly. Here it is including the transformation, lighting, primitive assembly, clipping, projection and viewport mapping. Next is a third stage is a rasterization. This stage produces fragments which are series of frame buffer addresses and values from the viewport mapped primitives as well as bitmaps and pixel rectangles. Then the fourth stage is the pre-fragment operation. Before fragment go to the frame buffer, they may be subjected to a series of conditional tests and modifications such as blending or Z-buffing. Parts of the frame buffer may be feedback into the pipeline as pixel rectangle. Texture memories may be used in the rasterization process when texture mapping is enabled. Next, we will see what are the types of OpenGL functions. Setting function. Here it will enable or disable functionality. Control OpenGL state. The examples are alpha transform. Here we can give some example. GL enable, capability, GL disable capability, GL light, FY light, P name, P value, GL translate X, Y, Z. Next type is data handling functions. Create persistent structures, involves memory allocation. Example, texture loading. The example is GL vertex pointer, GL gen textures, that is size name, GL delete textures, size name, GL text image 2D target level. The next function is rendering functions, that is draw and texture primitives. Examples are triangles and quadrilateral. GL begin, GL end, GL vertex X, Y, Z, GL draw elements. Next, we are going to see what are the primitives. I already told the primitives that comes under points, lines, polygons, that will come to the geometric primitives. We will see what are the primitives here given. Points, GL lines, GL line strip, GL line loop, GL polygon, GL quad strip, GL triangle fact, GL triangles, GL triangle strip. Okay, we will see each primitives, how we represent it in OpenGL. GL points. It will treat each vertices as a single point. Vertices n defined as a point n. N points are drawn. The sample is GL begin, GL points, GL vertices 2F, X, Y, GL end. Okay, why we have given here 2F is nothing but we are representing for a 2D function. That's why we are giving the 2F. Next one is GL lines. Treat each pair of vertices as an independent line segment. Vertices 2n minus 1 and 2n. Define a line n. N by 2 lines are drawn. The sample is GL begin, GL lines, GL vertices. We are giving the 2D representation. So X, Y, GL vertices 2F, X, Y. Here we are saying that lines. Already you have seen the primitives. Lines. We have to give lines. No, 2 points we have to give. 2 vertices. So we are giving the 2 vertices. GL end. Next is GL line strip. Draw a connected group of line segment from the first vertices to the last. Vertices n and n plus 1 define line n. N minus 1 lines are drawn. The sample is GL begin, GL line strip, GL vertices 2F X, Y, Y1, GL vertices 2F X2, Y2, GL vertices H3, Y3, GL end. Next one is GL line loop. We are going to give loop. For loop we have to how we will represent. Draw a connected group of line segment from the first vertices to the last. Then back to the first vertices n and n plus 1 define line n. N lines are drawn. The program will be GL begin, GL line loop, GL vertices 2F, X1, Y1, GL vertices 2F, X2, Y2, GL vertices 2F, X3, Y3, GL end. The next one is GL triangles. Treat each triplet of vertices as independent triangle. Vertices 3n minus 2, 3n minus 1 and 3n define triangles n. N by 3 triangles are drawn. GL begin GL triangles, that is triangle no. How we will represent 3 lines will be joining. We have to given 3 vertices. Okay, GL vertices 2F, x1 comma y1 GL vertices 2f x2 comma y2 GL vertices 2f x3 comma y3 GL end. Next one, quadrilateral. GL quads. Treat each group of 4 vertices as an independent quadrilateral. Here we are giving the 4 vertices. Vertices 4n minus 3 minus 4n minus 2 comma 4n minus 1 and 4n. These are the 4 vertices. Define quadrilateral n. N by 4 quadrilaters are drawn. Here we are giving the 4 vertices for quadrilateral. GL begins GL quads. GL quad vertex x1 comma y1. GL vertices x2 comma y2. GL vertices x3 comma y3. GL vertices x4 comma y4. GL end. Next we are giving triangle strip. Draw a connected group of triangle. Here we have to draw a connected group of triangle. One triangle is defined for each vertices represent after the 2 vertices. For odd n, vertices n, n plus 1 and n plus 2 define triangle n. For even n, vertices n plus 1, n and n plus 2 define triangle n. N minus 2 triangles are drawn. Here we are going to for the function GL line triangle strip. Here we are giving the 3 vertices x1 comma y1 x2 comma y2 x3 comma y3 GL end. Next one, triangle fan. Draw a connected group of triangles that fan around a central point. One triangle is defined for each vertices presented after the first 2 vertices. Vertices 1, n plus 1 and n plus 2 define triangle n. N minus 2 triangles are drawn. Here we are going to give the function of GL triangle fan. Here we are giving 4 vertices x1, y1, x2, y2, x3, y3, x4, y4. GL end. Next we are going to give the quad strip. Here we draw connected group of quadrilaters. One quadrilateral is defined for each pair of vertices presented after the first pair. Vertices 2n minus 1, 2n, 2n plus 2 and 2n plus 1 define quadrilateral n. N by 2 minus 1 quadrilaters are drawn. Here we are going to give how many vertices? 1, 2, 3, 4 vertices we are going to give. And these are the first, we have to give the function, first function GL behind quadrilateral strip. Vertices x1, y1. Here we are giving a 6 vertices and GL end. Next one is GL polygons. Here draw a single and convex polygon. Vertices 1 through n define this polygon. Polygon is convex if all points on the line segment between any 2 points in the polygons are at the boundary of polygon line inside the polygon. The sample, we will see the sample program. GL begin GL polygon. Here we are giving the 5 vertices, that is x1, y1, x2, y2, x3, y3, x4, y4, x5, y4. Then GL end. Thank you.